All right, so now that we've finished talking about how to calculate all of these delta H values, let's just kind of wrap this chapter up with talking about how to be responsible. So within the U.S., we generally have multiple sources of energy, but primarily they are petroleum, meaning oil, natural gas, coal, nuclear power, and then our various renewable energy sources, solar, wind, those sorts of things. So burning, these are generally fossil fuels. A lot is going to be what those are related to. So can we result in different types of air pollution? So sulfur oxides, this can be SOx. X can be 2, 3, 1. So just gases that are sulfur based, generally SO2 and SO3. Generally result from burning coal, and these by themselves are irritating to the lungs, or irritating to the eyes. They smell bad, and environmentally, we're primarily concerned with them and their contribution with acid rain. There. Carbon monoxide pollution can come from the incomplete combustion of fossil fuels. And so when we were doing some of our calculations, it said complete combustion, combustion. Well, sometimes these reactions don't always go to completion, so you can still end up with carbon monoxide. Usually this is associated with cars and engines. Carbon monoxide is a problem because it binds to hemoglobin in the human bloodstream much better than oxygen binds to hemoglobin. So carbon monoxide poisoning, silent killer, very dangerous. Turn the page. There are also nitrogen oxides. So in this case, the X can be 1 or 2. So nitrogen monoxide, nitrogen dioxide. This happens when burning processes very high temperatures. You see this a lot of in the deserts or things like that. Obviously, burning processes are pretty high temperature anyway. This is what's going to form that dark haze that you kind of see over some pollutants, that smog. Those are nitrogen-based pollutants. And then you have ozone. Ozone, when it's way up in the atmosphere, is a good thing. Ozone down here is not necessarily a good thing. All right, so when you have fossil fuels, and then you have some of that unreacted volatile organic compounds. Volatile means they are gaseous. They form vapors. So organic compounds that are vapors. And those two things are going to react in sunlight. And they're going to produce ozone. And ozone itself is a component of what you may have heard of P-T-R-O, I can't spell, petrochemical smog. And when it's low in the atmosphere, it can cause lung irritation. When it's up where it belongs, it helps prevent sunburns and UV exposure. But ozone is also released from lightning. Happens there. All right, so those are some practical applications there of pollution and types of heat and combustion things. So if you're interested in environmental applications of engineering, this is for you.